So this question says express each relation below as a set of ordered pairs and determine whether it is a function or not. Now, if you remember from the previous explanation, I said a function is a special type of relation in which each element of the domain represent the x-axis or x component, is paired with exactly one element in the range, meaning that the domain can only be paired with one element in the range. It can only take one element in the range, meaning that x can only take one element from y. A single x cannot take two elements from y, meaning that I can say, this single x is now connected to 7, and then I'm now having another this single x again connected to -2, but y can connect to more than one x, but x cannot connect to more than one y. So like this y now is connected to 2x, but this x cannot connect to 2y. So that is what a function is. So we are required to express each relation that is given below. You can check the previous video for the detailed explanation whether it's a function. So for us to know if it's a function, we have to check for those properties. So first of all, let's look at this question A. So by looking at this question A, by observation, if we want to write it in coordinate form, this one will be what, -3, 7. Then this one will be what, -1, -2. This one will be what, 0, what, -2. And this last one will be what, 4, -9. It has been written in ordered pair. And if you look at it, we notice that each element of the domain, right, is paired with exactly one element, right, of the range. So this particular mapping here represent a function. So yeah, I've just explained that. You can check the previous video for detailed explanation. Meaning that x is not taking more than one, it's not connected to more than one value from y. However, y can connect to more than one value from x. So it's a function because each of the elements in the domain is not taking more than one element in the range. All right, so that is that about that. So that is for A. Then let's get to B. So for B, don't forget the question made it clear. It says express each relation below a set of ordered pairs. So this is the ordered pair for A. So let's get the ordered pair for B. To get the ordered pair for B is not scaled. The graph is not scaled. So we would scale it. Let's say this is 1, this is 2, this is 3. And then obviously this will be what, -1, -1, -2, -3, and so on. This one, so let's take this as -1, -2, -3, -4. So this will be 1, 2, 3, 4. Okay, so but this particular point here is located in the coordinates 1, 1, meaning that when x is 1, y is 1. So this is 1, 1. This other one is located at what, -2, 3. So this is what, -2, 3. While this one is located at -2, -1. That's x is -2 and y is -1. So this is -2, -1. And this other one is located at what, x is equal to 3 and y is what, -4. All right, so if you are writing the ordered pair for this, let me call this A, let me call this B, let me call this C, and let me call this D. That will be what, A, that is 1, 1. Then B, I have -2, 3. Then I have C, that's -2, -1. Then I have D, which is what, 3, -4. So that is that for that. Now the question is, does it represent a function? Now for us to know if it represents a function, does any element in the range, in the domain, pair with more than one element in the range? Let's check it. If you look at 1 to 1 here, -2 to 3 here, -2 to 1 here, then 3 to 4. The best way we can actually determine this is to actually put it in form of mapping. The reason why I said if we put it in form of mapping will basically, you know, give us a clear description. So let me put it in mapping form, just like the mapping I have, you know, here. We've represented it in ordered base, so don't mind my handwriting. So all the domain values, right, we have 1, -2, -2, 3. So if we arrange it in ascending order, that is -2. We can't write -2 twice for the mapping. -2, that is then 1 and what, 3, right? Because 1 -2 -2, so -2 appears, right? Then for the what range, we have what, 1. Let's see, we have 3, we have -1, we have -4. So we can write -1, -4, right? -1, -4, then 1. Okay, -1, -4, we have 1 and 3, 1 and what, 3. So if you do the mapping 1 to 1, so 1 to 1, then -2 to 3, -2 to 3, right? Then let's look at it again. Then -2 to -1, -2 to what, to -1. Then we have 3 to what, -4, 3 to excuse me, 3 to -4. So by observation, does this represent a function? For it to represent a function, every element in X, right, cannot be merged. I mean, every element in X cannot be merged with 2 elements in Y. So if you look at it, we can see that 3, right, and what, and -1, I'm saying that the element -2 in the domain, this -2 in the domain is paired with both 3 and -1, so it can't take 2 elements in Y. So in that case, this particular what, this particular function, I mean this particular graph does not represent a function. So our conclusion is that not a what, a function. So it doesn't represent a function, all right, because X is taken, that is -2 is taken -1 and -3. It cannot take 2 elements from Y. That's very important. This is X, this is Y, but Y can take 2 from X, just like what we have here. Y take 2 from X, but X cannot take 2 from Y. So that is B. Then lastly, C. This one, okay, this is a table directly and it has been arranged. So 1 to -2, right, 2 to 3, 3 to 5, 4 to 2. Obviously 1 is not taking more than 1 from Y, 2 is not taking more than 3, then 4. So this one is straight to the point. This particular one, this table represents the function basically because each element in the domain, thus each element in X is paired with exactly 1 element in the range, which is what, Y. So this is a what, this is a function. So from the 3 different pattern given, this is mapping, this is a function, this is a function, graph here is not a function, not a function, and this one is a what, is a function. So I want to believe this video has helped someone. Thank you for watching and see you in the next video. Bye bye.